Hey, good morning or good evening, actually, all you MRWC fans. This is Mr. Aynesworth, and we're going to get into a really cool activity and learn how to multiply and divide complex numbers in trigonometric form. How do you do it? And versus me just telling you, okay, which won't teach you very much, we're going to learn by doing, and we're going to express some numbers that are given in complex form or Cartesian form, and we're going to get all of the complex numbers in trig form, and we're going to analyze the results. Okay, so we're given z1 here and z2. Those are our original complex numbers. We're going to get those both in trig form. Then we're going to multiply them in Cartesian form, and then we're going to divide them as well. And then we're going to get all these four numbers, z1, z2, z3, z4, in trig form, which you already know how to do. And then when we look at the results, you're going to be astounded, or actually astonished, okay, amazed, if you will, the relationship between the complex numbers, all right, and their product and the quotient. So how do you multiply them? How do you divide them in trig form? It turns out to be extremely easy. All right, so in order to do that, in order to see it, okay, you have to express all the complex numbers here in trigonometric form. Okay, so it says express the three complex numbers. Well, guess what? There's a little typo right there. Express all four of them. Okay, there's four: z1, z2, z3, z4. All right, so let's get with it here and let's kick in our skills that we already know. Okay, so this is called Cartesian form: a plus bi. Okay, what's called Cartesian form. Okay, and what we want to do is we want to express it in trig form. All right, to do that we graph it first, as you guys already know. I'm going to change the scale a little bit just to make things a little bit bigger here. Okay, so every 2 units is equal to 1, okay, or 2 squares equal to 1. Just change the scale just to make things bigger. Not that you have to, but if I didn't, the picture would look extremely small. All right, so I'm going to go left 1, down 1. So I'm going to go left 1, down 1, plot. So there's z1. I'm going to draw the triangle like we always do, and then draw the radius, or the modulus, excuse me. And then I'm going to draw theta. Now remember, theta always starts off on the real axis at 0 degrees, going in a counterclockwise direction. Okay, CCW is counterclockwise. So theta always starts on the real axis at 0 degrees, rotates, and you stop at the modulus. It's that simple. So there's theta. So if this is 0 degrees, up top is 90, and this is 180, and down here is 270, and then right back to the real axis, well, that's the same thing as 360, or a full revolution here. Okay, this is the real axis. We know, just by looking at the picture here, that theta's got to be bigger than 180 and less than 270. Okay, what's good is that I noticed that both sides are length 1. All right, I went left 1 and then I went down 1. Okay, so this is an isosceles right triangle, and you guys know about these. We talked about these in the very first lesson, and all isosceles right triangles are called 45, 45, 90s that you learned in geometry. So I know that this little angle in here, okay, let's look real closely right in here, inside the triangle is 45 degrees. So if you go halfway around, which is 180, you got to go another 45. So already I know, all right, just by examination, all right, that theta has to be 180 plus 45, all right, which means theta is 225. Okay, already know that. Now if you want to use your tangent function, okay, and use your calculator, you can. If you didn't see that it's isosceles, then I guess you would have to. All right, but remember, tangent of theta is always b divided by a. Okay, and a and b are both -1. So in this case, tangent theta is -1 divided by -1, or 1. So if you take the inverse of tangent, you'll get your theta. Okay, and so if we do that, let's bring in the Desmos here. Okay. All right, so kick in Desmos here, go function, inverse, and then type in 1. Go back to the main menu and type in 1. Notice you get 45 degrees, right? That's a quadrant 1 angle, and notice it's positive. If you plot 45 degrees, be here, there's 45 degrees clockwise, counterclockwise. Positive angles go counterclockwise, okay? And negative angles go clockwise. So you graph 45s. You'll notice that that is not the angle we're looking for. We're looking for theta, which is between 180 and 270. So if you use the calculator, it'll give you 45 degrees, but to get to quadrant 3, you got to add 180 to it. And so therefore, theta is 225. Okay, now what's the modulus? So let's get that. So r is equal to the square root of a squared plus b squared, as you guys already know. So r is equal to the square root of -1 squared plus -1 squared, which happens to be the square root of 1 plus 1, or rad 2. Okay, so there's your modulus. Okay, now here comes the form. So let's do polar form first. And right here, polar form is r comma theta. So r comma theta for this one is root 2 comma 225. Okay, trig form is what we need though, so let's write that. Okay, so z1 is equal to root 2 times cosine of your angle, 225 degrees, plus I times the sine of 225. Okay? All right. So now let's highlight this. That's my first main result. Okay? We need to do this for all 4 complex numbers. So here we go. Let's do it again. Okay, so for z2, -1 plus I, that's graphed as -1 comma 1. So left 1 up 1. So there's z2. Now we're in quadrant 2. So this one was quadrant 3, Q3, quadrant 3. This one's in quadrant 2. So I went left 1 and I went up 1. Remember, I changed the scale here. So up here is at 1. And then the modulus is here. Okay, so -1, 1. And so now theta is between 90 degrees and 180. And remember, this is still an isosceles right triangle. I know this angle in here is 45. So it's not quite a half revolution. I got to take 180, but I got to go back 45. So really, it's really 180 minus 45, which happens to be 135. I know that without even doing any trig. Now, if you didn't notice that, you could use your tangent function again. So you take b divided by a, so 1 divided by -1, which happens to be -1, and then you take the inverse tangent of -1. Now watch what happens on your calculator here. So you go inverse tangent, type in, go back to the main menu, type in -1. Oops, sorry. Oh yeah, and you get -45 degrees. So, but that's not our angle that we're looking for. This is clockwise. Negative angles go clockwise, and then positive angles go counterclockwise. So -45 degrees, if you're going to draw it, is here. That's not what we want. We want it supplement, so we have to add 180. And so theta is actually 135. All right, -45 plus 180 is the same thing as 180 minus 45, which is 135. Okay, now because it's the same triangle as the first one, I know the modulus is root 2. So I'm not going to, do that again. So I know that the modulus is root 2. So now we're almost done for this one here. Polar form, which is just r comma theta, is root 2 comma 135. Trig form, that's the one we're really interested in here. Okay, so z2 now is equal to r, which we know is the same as the previous one, root 2 times cosine of our angle 135 plus I times the sine of 135. Okay, so that's our next main result. And once again, if I am going too fast, okay, you got to slow me down, okay? Now I always tell you guys to go at your own pace in your videos, okay? Why? Because you want to strive to understand. And if you just blind copy like some of you guys are doing, you're not going to learn a damn thing. Okay, so you got to slow down. Go slow at your own pace and strive to understand. Otherwise, you're not going to be able to apply it. Guarantee it. Okay, now what we need to do is multiply z1 and z2 and then get that in trig form and do the same thing for z4. And believe it or not, it's not that difficult. Okay, so here we go. Let's multiply first using FOIL or distributive property. Working on z1 times z2 here, so -1 times -1, so distribute, right, is 1, right? -1 times I is -I. -I times -1 is positive I. -1 times, -I times I is a -I squared. So when you simplify, this right here becomes 0, right? Negative I plus I is 0, and you get 1 minus I squared, which is negative 1, and so the end result is 2. So Z3 is equal to 2, which happens to be the same as 2 plus 0I. And the reason why I say that is because you're going to have to graph 2 comma 0. That's what you graph or plot. Okay, so let's do that. So I'm not going to change the scale here like I did on the first 2 graphs because I'd be off the grid. So if this is 1 and this is 2, then here's Z3. Okay, now notice it's on the real axis. So it's on 0 degrees or 360 degrees. So 0, 90, remember up at the top is 90, and then 180, and then 270, and then right back at 360. And make sure you write down both 0 degrees and 360 degrees because I'm going to write Z3 2 different ways. Okay, now notice something here. This is on the real axis. So right here, the distance between the pole, okay, this is called the pole or the origin, right? The distance between the pole and Z3, well, guess what? That's the modulus. All right, so R here is equal to 2 because it's simply 2 units away. And believe it or not, theta is equal to 0 degrees or 360, right? Because it's the same. Okay, you could rotate 360 degrees and you end up at the same place. That's why they were equivalent. Believe it or not, polar form, you can have many or an infinite number of representations of the same form. Okay, so polar form first, that's just r comma theta, so that's just 2 comma 0 degrees or 2 comma 360. There's your polar form. Now trig form, here we go. So that Z3 now is equal to 2, because the modulus is 2, times cosine of 0 degrees plus I sine 0 degrees. Or you can write Z3 using the other angle, which is equivalent to 0 degrees, which is 360. Make sure you write this down because I'm going to use it here in a minute. We're almost done. Okay, so we got 2 different ways to write Z3 because 0 degrees and 360 are equivalent in terms of polar angles. Okay, last one, Z4. We got to divide the original 2 numbers, Z1 divided by Z2. It's called a quotient. Okay, now to do that, we got to multiply by its conjugate. So the conjugate of negative 1 plus I is negative 1 minus I. You do that in the form of 1. And when you do this, make sure you put parentheses around everything because they're binomials. Okay, so I'm using the conjugate here, which you guys learned a long time ago. Okay, in MRWC, we build up on everything. Okay, all the concepts that you learned a long time ago, well, guess what? We need them now. Okay, multiply again. So negative 1 times negative 1 is 1. Negative 1 times negative I is I. And then negative I times negative 1 is another I. And then negative I times negative I is positive I squared. Okay, same thing on the bottom. Here we go. You can use structure down below, though, if you want. I like using structure. As you guys know, this is a plus b times a minus b because they're conjugates. And that's always equal to a squared minus b squared. So all I have to do is square both and subtract. Okay, here we go. So up top, negative 1. This is equal to negative 1 here. And the positive 1, they cancel. Okay, and all you get is 2i up top. So 2i's up top. And then down in the denominator here, I got 1 minus a negative 1. 1 minus a negative 1. I squared is negative 1. And that's just 2. So really I have 2i divided by 2, which is simply I. So there's Z4. I. You can write I in Cartesian form is 0 plus I. Okay? What you kind of want to do, because you want to graph that. And to graph that, you graph 0, 1. Okay, so let's do that. Let's graph 0, 1. Let's go up 1 unit here. Call that 1 unit, and this is Z4. So notice on this one, if the real axis starts at 0 degrees, and here up at top here is 90, then I know the polar angle, all right, from here to here, I know the polar angle is 90 degrees. I also know the radius, or the modulus here is 2, so R is 2. Just like on the previous one for Z3, if you're, not 2, I'm talking about 1, sorry, or 1 unit up, so let me change that. R is equal to 1 because we're 1 unit up. the distance between the point and the pole is 1 unit, not 2 units. So don't look at the grid lines. I labeled that 1. So don't let that fool you right there. Okay, so here we go. Let's write it in trig form. So z4 is equal to 1 now. The modulus is 1 times cosine of 90 degrees plus I times the sine of 90 degrees. Now, because we're not distributing anything here, I can just drop the parentheses. So z4 is just cosine of 90 plus I times the sine of 90. Okay, so now we have our 4 results. Now what we want to do is put them together. Okay, let's form them in our table and then compare. And you're going to be shocked at the results of what happens here. So z1 up top, at the top of the screen, so it's root 2 times cosine of 225 plus I sine 225. z2 is root 2 times cosine of 135 plus I times the sine of 135. z3, I'm going to use the second one. You'll see why here in a minute. It's easier to see. Just trust me on this because I have some experience here. So I'm going to use the angle of 360, not 0. Okay. So plus sine, or I times sine of 360. And then let's bring this last one in. Okay, z4. Okay, z4 is on the last row here. Is cosine of 90 degrees plus I sine of 90 degrees. Okay, and now what we want to do is look at the relationship. Okay, here we go. So what we want to do is compare. It says, what pattern do you see in the moduli? So let's look at the top of the screen. Let's clear everything else out. So what pattern do you see in the moduli? Question 1. So this is Q1. And then Q2, what pattern do you see in the polar angle? So let's analyze the modulus first. Okay, moduli is plural for modulus. Kind of like octopi and octopus, okay? Okay. All right, so let's highlight them. So first modulus is root 2. Next modulus is root 2. And when you multiply z1 times z2 to get z3, okay, we got a new modulus of 2. What pattern do you see in the modulus? What do you do with root 2 and root 2 to get 2? Okay, so remember, this is the modulus right here. So tell the person next to you, what do you do to root 2 and root 2? Okay, these two moduli right here, because we're multiplying them. Again, look at this. Z3 is found by multiplying Z1 times Z2. So what do you do to the moduli to get to the new modulus? Okay, what do you do with root 2 and root 2 to get to 2? All right, and if you said multiply, that happens to be correct. Okay, so root 2 times root 2, well, guess what? That's just 2. Okay, so you simply multiply the moduli when you multiply complex numbers. So whatever those two moduli are, just simply multiply them together. We'll write that down in a minute. Okay, so when multiplying two complex numbers in trig form, okay, you multiply the moduli, okay, and you do something else, okay? So now we have to take a look at what pattern happens in the polar angles. Okay, so let's focus in on the angles now. So the first angle is 225, the next one's 135, and then the result, the angle in the result, after you multiply them, is 360. Oh my God. Okay, so what do you do with the polar angles? These angles here. What do you do with 225 and 135 to get 360? What do you do? Tell the person next to you. Do you add, subtract, multiply, divide? What do you do? Okay. Well, let's see here. If you took 225, sorry. All right, and you added 135, let me see, 200 and 100 is 300, 25 and 35 is 60, you get 360. Oh my God. You add the angles. Add the polar angles. Okay, so let's answer our question here. When multiplying complex numbers in trig form, multiply the moduli and add the polar angles. That's all you do. Believe it or not, it's that simple. Multiply the moduli and add the polar angles. You'll see that in when we get here. When we start applying everything, that's all you do. Now, when you divide complex numbers in trig form, okay, something else happens. Okay, so now we got to compare the first two numbers here, z1 and z2, with z4. So get your eyes off z3. Don't look at z3 anymore. Okay, look at z4. So now look at the, let's see here. Look at the moduli, root 2 and root 2, and look at the new modulus, which happens to be 1. I didn't write it there, but the new modulus for z4 is 1. So put that back, actually. And ask yourself, what do you do with root 2 and root 2 to get 1? Because this is the new modulus right here. Okay, so I should have kept it there just so you can guys see what's going on here. So do you add or subtract the moduli to get the new modulus? What do you do with root 2 and root 2 to get 1? Okay, and hopefully you see that root 2 divided by root 2 is 1. So you want to divide the moduli. So on the first one, we said, okay, well, if we multiply the numbers in trig form, then we multiply the moduli. Okay, well, if you divide numbers in trig form, divide complex numbers in trig form, that is, all right, you divide the moduli. So when dividing two complex numbers in trig form, let's write the result here in red. Okay, you divide the moduli, because root 2 divided by root 2 is 1. So divide the moduli. Okay, and, okay, now what do you do with 225 and 135 to get to 90? All right, so the new polar angle is 90. So before, when we multiplied them, you added the polar angles to get 360. Here we got 225 and 135. How do you get to 90? Tell the person next to you. What do? Add, subtract, multiply, divide, square, square root. What do you do? And if you were thinking that you subtract these angles, let's see. So 225 minus 135. Well, guess what? That's equal to 90 degrees. Okay? So if you said subtract the angles, you were correct. Okay. So let's write that in big, bold, and red. So when dividing two complex numbers, first divide the moduli and, okay, subtract the polar angles. That's all you do. And these are the key ideas, so make sure you bold them, okay? In any activity, the end result is what matters. We did all this arithmetic here to simply get the full results, because if we didn't have the results in trig form, there's no way for you to see it, okay? And that's the beauty of these activities, is that if you do the mathematics right through the activity and you analyze and you can actually think about the results in the activities, you can make connections at the end and learn all the main ideas. Okay? All right. Now what we want to do is go to page, I think it was page 36, I think, in your notebook. Okay, so go to your notebook and hang on. Let me find out. Where's mine? Okay, so go to page. What happened here? Hang on for a second. What's going on? Oh, you know what? Okay, so let me see. Let's figure out where this is. It's after 5D1 part 4. So it's after 5E. So instead of going into 5E 1, 2, and 3, okay, which is in your notebook, okay, go past that. Okay, hang on. Okay, let me get my section 5. There we go. There's the part. So we did part 4 today, and then we quizzed. So after that is 5E1, 5ET, 5E3. Keep going. Here it is right here. This is on page 36. Go to this page here. This is what we want right here. Okay. So now let's apply what I'm talking about. Again, this is page 36 in your notebook. So we're going to work on page 36 and 37. Yeah, okay, so here we go. So on this one here, let's go to our first example here. We're given z1 up top. So we're given two numbers in trig form, z1 and the next one, and the next one z2. Okay, we're given those two numbers here. And what we want to do is multiply them. Okay, z1 times z2. And so what I said before is you got to multiply the moduli. So what is that? So right here is multiplying the moduli, this part right here. And then you add the polar angles, and that's what theta 1 plus theta 2 is. You add the polar angles. So when I do this here, okay, I get z1 times z2 is equal to, and I look at r, the first r value. So my modulus of z1 is 8. Okay, my next modulus, okay, is 2. So this is going to be 8 times 2 times cosine of the sum of the polar angles. I got to take 135 here and add it to 15. So 135 plus 15. Okay? Plus, okay, I times the sine of the sum of the polar angles. Now 135 plus 15, whatever that is. Okay? Okay, so let's simplify. So 135 and 15, that sounds like 150, right? So this is equal to 16 times cosine, let me switch up on the brackets here. All right, cosine of 150 now, plus I times the sine of 150. You can use round parentheses if you want, that's fine. Okay, and then all you do is use your unit circle. Okay, so you go to unit circle here. All right, you got to find 150, which is quadrant 2. Okay, doesn't matter which, well, it doesn't matter which one. I broke these unit circles, I broke it up into parts. So put the angles that are multiples of 45 on the left and then multiples of 30 on the right. So 150 happens to be here. All right, and so the cosine of 150 degrees is negative root 3 over 2. Okay, so here we go. So we got 16 times negative root 3 over 2. Plus I times the sine of 150, and if you go back to unit circle, the sine is a y-coordinate, which is equal to 1/2. So always have your unit circle here. So this is going to be times 1/2 using the unit circle. Okay, so now distributing through, I get 16 times the negative rad 3 over 2 plus 16 times I times 1/2. Okay. Now, as you guys know, 16 divided by 2 is 8, so I get negative 8 rad 3. And then 16 divided by 2 is 8 here, and I get 8i plus 8i. There we go. And that is Cartesian form, a plus bi. It's called Cartesian form. Okay, so all you do is multiply the moduli and add the polar angles. That's all you have to do to get to do that in trig form. It's that simple. Now when you divide, that's different. Okay, so here we go. Now dividing z1 by z2, the same two numbers up top, but this time we're going to divide. Okay, we got to divide the moduli, r1 divided by r2. So I got to take 8 divided by 2 times, okay, cosine of the difference between the angles. So I got to take 135 minus 15. So 135 minus 15, whatever that is, plus I times the sine of 135 minus 15. Okay, so now let's get started. 8 divided by 2 is simply 4 times cosine of 120 plus I times the sine of 120. So all we have to do is go to the unit circle again and get our values. Okay, so let's do that. So we got to find 120. So 120 degrees is up here. Okay, so the cosine is negative 1/2. The cosine of 120 is negative 1/2. So negative 1/2 here plus I times the sine of 120. If you go back up there, the sine of 120 is root 3 over 2. Okay, so times root 3 divided by 2. Multiplying through, so you get 4 times a negative 1/2 plus 4 times I times rad 3 over 2. You just simplify a little bit. 4 divided by 2 is 2, so you get negative 2 here. 2 times negative 1 is negative 2. 4 divided by 2 is 2 again, and you get 2I root 3 plus 2I root 3. And that is Cartesian form again. Okay, so when you deal with complex numbers in complex form, like the two that I started with up top of the screen right here, z1 and z2, when you multiply them, you simply multiply the moduli and add the angles, and then convert. When you divide them, you divide the moduli and subtract the polar angles, and then convert. Excuse me, okay? And that's all you do. So, your turn, okay? So you have actually, you just have 3 examples here, okay? And just read the directions here. Z1 and Z2 are up at the top here. They change depending on the problem. And then you'll have to multiply first and then divide, okay? And think simple. And once again, think simple, okay? When you multiply, one more time, when you multiply numbers in trig form, you multiply the angles, or the moduli, excuse me, you multiply the moduli and you add their angles. And then when you divide complex numbers in trig form, you divide their moduli and subtract their angles. There you go. All right, so you go ahead and continue here. You finish page 37, and then I will see you back in class at another date. Okay? This is Mr. Aynesworth, and hopefully I get well and I can come back soon. See you then. Bye-bye.